yn plus h f of x and yn. So this is what we have, and then our h now is 0.05, so this becomes yn plus 1 equals yn plus 0.05 into f of x and yn. So this is our x squared. That's going to be xn squared plus yn squared. So this is going to be paradigm for finding the approximate y value at x equals 0.5. So that's what we're going to have. So what we have is we're going to have like we did before. So you have your x and here you have your yn here, and then we're starting with 0, which is the initial condition, starting with 0, and then now we're going to 0.05. So to get the 0.05 with that, what we'd use is 0.05. The next one's going to be 0.1, 0.015, 0.2. So we go to 0.25, 0.3, 0.35, 0.4, 0.45, 0.5. So that's what we'll do, and then we are told that the same way the y value at 0 is 1. So we're going to be using the same thing. Maybe I should write an n value here, and then this is going to be when n is 1, n is 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So y1 is 1. So I want to find y2. So to find y2 here, that is when n is 1, you have 1 plus 1, that's 2. So to find y2, so you have y2 equals y1 plus 0.05 into x1 squared plus y1 squared. And our y1 is 1 plus 0.05 into x1 squared. That's 0 plus 1 squared, which is actually 1 plus 0.05, which is 1.05. So that's going to be the first value you would have, 1.05. Now for the third part, which is y3, so for y3, to get 3 here, n has to be 2. 2 plus 1 should be 3. So you have y3 equals y2 plus 0.05 into x2 squared plus y2 squared. And then your y2 was what we obtained here when n is 2, that's 1.05. 1.05 plus, you now have 0.05 into x2 squared, that's 0.05 squared plus y2 squared, which is 1.05 squared. 0.05 squared. And then when you simplify this, what you obtain is 1.1053. 1.1053. So you continue the whole process on and on and on in the same manner. And then when you keep doing that, what you would have for the next one is 1.669, 669. You should do this and confirm that your answers are the same thing. 1.2361, 1.2361. Next one is 1.3145, 1.3145. Next one is 1.4040, 1.4040, 1.5071, 1.5071, 1.6268, 1.6268, 1.7671, 1.7671, and the last one is 1.933, 1.9334. So this is what you'd have here. So using a step of h equals 0.05, we had our y value that is y of 0.5 equals 1.9334. So this is what we had for the y value here. So compared to what we had initially, our y value here was 1.8370, but our y value here is 1.9334. Actually, this is going to give you a more accurate answer when you compare it by solving this. So I'm going to leave the part B for you to try, but I'm going to put down the answers there for you, so to ensure that you got your answer. So for doing the part B, that is y prime equals y minus y squared. For doing that part, so your f of xy here is going to be y minus y squared, and that implies that your f of xn yn is going to be yn minus yn squared. That'll be your f of x and yn. And then to use the Euler's algorithm, which says yn plus 1 equals yn plus h f of xn yn. So that'll be yn plus your h into yn minus yn squared. So this is going to be what you use as a paradigm in trying to solve the next one. And then what you'd have is for your h equals 0.05. Using h equals 0.05, the y of y value should be approximately 0.6228, and then when you use a step size of 0.1, the y value that you should obtain at that point actually should be 0.6231. 0.6231. They're actually very, very close, but this seems to give a more accurate answer compared to that. And that completes the problem.